Welcome, everyone. Uh, Last week in chapter one, we talked about the conceptual framework, systems, resilience, planetary boundaries, and so on and so forth. This week, we'll ask, how do we get here? Understanding the past helps us plan for the future, as different researchers in previous chapter, like Costanza and other colleagues, noted that understanding the past would help us better plan for the future. These seven objectives outline our path for this chapter, chapter 2, spanning from early 19th century conservationists to the planetary boundaries of the Anthropocene. So, our key theme we'll explore is that environmental progress requires the convergence of multiple disciplines. Rigorous science, like that of Rachel Carson's, is critical, but as we will see, it requires the addition of grassroots activism, ethical shifts, and legislative action to enact permanent environmental reform towards sustainability. Long before sustainability was a word, these five incredible thinkers or philosophers, Thomas, Henry, George, John, Arrhenius, and Tyndall, uh, laid the groundwork by challenging the belief that nature's resources were inexhaustible. Malthus in 1798 argued population grows geometrically while food grows arithmetically. So, called as the Malthusian cycle, the first quantitative limits to growth argument. Thoreau at Walden Pond saw nature as an interconnected community. Marsh's Man and Nature, 1864, framed stewardship as an ethical duty. Again, John Muir championed intrinsic value and founded the Sierra Club. Tyndall and Arrhenius, 1908, made the first quantitative climate prediction linking fossil fuels, particularly coal burning, to planetary warming. So these um, uh, people were warning us way before that then we realized the climate change is real. So these individual observations soon matured into an entirely new scientific discipline. The 20th century reframed nature from a managed resource into a web of interdependent relationship. Examples: Pinchot treated forest as a crop for human benefit, and were countered with intrinsic worth. Elton's 1927 food pyramid showed humans are far from indispensable. Lose the top predator and little changes, lose the base, it will collapse. So again, Tansley coined ecosystem in 1935. Clement saw communities as organisms like wholes moving towards climax. We'll maybe talk about this climax concept later in the semester. Autumn warned maximizing productivity degrades ecosystems in 1960s, and Pickett and White 1985 showed ecosystems are very dynamic. They are not stable at all. So nature is more than we can ever master. Silent Spring turned rigorous ecological science into a public reckoning that launched the modern environmental movement. Carson and FWS biologists grounded her case against DDT in peer-reviewed paper uh, but wrote inaccessible poetic prose, making harm undeniable, empowering citizens, and linking wildlife and human health as one problem. The ripple effect followed very fast. Elrid's population bomb in 1968, the first Earth Day in 1970, where 20 million people participated, limits to growth in 1972, and Schumacher's Small is Beautiful in 1973. So that wave of public awareness didn't stay abstract. It was quickly written or converted into different laws and policies. So public outcry drove an extraordinary bipartisan decade of U.S. environmental legislation. The very first is NEPA in 1970, the Magna Carta of environmental law in U.S. histories, created the EPA, Environmental Protection Agency, which is central to protecting our environment. The Clean Air Act in 1970, which set not population, but pollutant standards. The Water Pollution Control Act 1972 targeted feasible and swimmable waters. DDT was banned in 1972 after Carson's publication. The Endangered Species Act 1973 protected species and their ecosystems. RCRA in 1976 regulated hazard waste. The National Energy Act in 1978 answered the oil crisis that happened at the time. At the time, the U.S. was not alone. Europe was undergoing its own environmental awakening at the same time. So scientists and politicians and people started realizing transboundary disasters pushed beyond boundaries. So transboundary disaster pushed Europe particularly toward cooperation, culminating in the first Global Environment Summit. So London's 1952 smog killed around 4,000 people and prompted the UK's Clean Air Act. The 1967 Torrey Canyon spill followed British and French coast. Swedish lakes acidified from foreign air pollution, proving pollution crosses boundaries. That need for cooperation and it produced the 1972 Stockholm Conference, where Indira Gandhi from India linked poverty and pollution, and later the 1987 Montreal Protocol, which phased out CFCs, chlorofluorocarbons, and remained the clearest success of cooperation for sustainability at the time. Gandhi's link between poverty and pollution not only helped forming different alliances, our government alliances, but also laid a foundation for environmental justice and equity. So environmental justice emerged where the civil rights and environmental movements converged around pollution's unequal burden. Chavez and Huerta's United Farm Workers in 1962 fought pesticide exposures in the field. At Love Canal, Louis Gibbs organized residents after toxic waste caused birth defects and cancer, leading to Superfund 1980. So in Warren County, 1982, Ben Chavez coined environmental racism after a PCB site targeted a black neighborhood. His 1987 report proved the pattern nationwide, establishing environmental, intergenerational, and social equity as sustainability's third pillar. So all of these questions of who deserves protection lead to a deeper questions, what deserves moral considerations at all. Environmental ethics ask whether nature has moral worth of its own, independent of human usefulness. Like we discussed the Pinchot forest in earlier slides, Pinchot represents instrumental value, Thoreau, Moore, and Leopold represents intrinsic value. So Leopold's land ethic extended ethics from individual to society to land itself, famously declaring the act right when it preserves the integrity, stability, and the beauty of the biotic community. Bentham and Singer extended the question to animal suffering. Stone's 1972 essay and later rulings, Ecuador's constitution, Bolivia's right of Mother Earth, and New Zealand's Whanganui River gave nature legal standings. These ethical ideas didn't stay in philosophy or just idea or thought. They helped shape decades of international cooperation, international governance. The international government's story of sustainability spans 5 decades, and so both the power and the limits of global consensus. Stockholm established the architecture of global conversation connecting environment and development. The Portland Report that we discussed last week, or even if not discussed, mentioned, gave it the defining vocabulary. So Rio 1992 was a high watermark of ambition. Agenda 21 was a comprehensive blueprint agreed by around 180 nations, but implementation of those agendas fell apart, or not entirely fall apart, but fall short. The Millennium Development Goals demonstrated that shared goals with measurable targets can drive real progress. Extreme poverty fell, child mortality fell, even when the goals are not fully met. So the SDGs represents the most comprehensive attempt yet, but at 17 goals and around 169 targets, they risk becoming unwieldy. The Montreal Protocol on Ozone, by contrast, succeeded because it was simple, verifiable, and addressed a narrowly defined problem with a concentrated producer. So any multinational or transboundary issues that deal with should be very narrowly focused by both the parties or multi-parties, and so on and so forth, to be a successful endeavor. So climate change lacks all of those features. While diplomats negotiated targets, the underlying data was telling an even more dramatic story of this kind of cooperations and different objectives set forth by this kind of bilateral or multilateral transboundary agreements. Since 1945, human activity and Earth system change have accelerated exponentially, marking a new geological epoch called Anthropocene. We discussed a great deal about this in last week. Croton and Stormer proposed Anthropocene in around 2000 to assess whether the Anthropocene or the areas of significant human impact on Earth qualifies as a former geologic epoch in the geological time scale, an Anthropocene Working Group was established in 2009. They conducted several studies and after studies. So figure 2.1 in the chapter or in the slide here plots 24 variables, population, GDP, carbon dioxide, temperature, ocean acidification, forest loss, and many more variables. Everyone traces the same hockey stick pattern. You can see in the figure. They are flat until 1950, then almost near vertical thereafter. What this graph or several other findings led or showed the evidence that led the Anthropocene Working Group to vote in 2019 by around 88% to mark the epoch's start at mid 20th century, not the Industrial Revolution, not after the Industrial Revolution. So we can read these curves as a summary of the cumulative result of Malthus predicted overshoot. If you remember the slide one, there's a Malthusian cycle that predicted overshoot playing out in real time. The period from the mid-1980s to the present represents the professionalization and institutionalization of sustainability. The ecological footprint gave the field a quantitative metric that most of the policymakers or even local people want to know about or tie it to some sort of economic value or economic metric. We could now calculate how many planet Earths would be needed if everyone lived like a particular country's average citizen. So a life cycle assessment moved this kind of analysis from the end of pipe or the pollution to the full supply chain and cradle to cradle in perhaps is perhaps the most intellectually elegant contribution of this period. Instead of trying to minimize waste, redesign systems so that there is no concept of waste. So the proliferation of certification program reflects a key challenging in sustainability, such as measurement, verification, and after that, certification. So there are various types of certification in sustainability. We'll discuss that also in later chapters. Higher education's growing engagement, hundreds of sustainability programs have led the institutional foundation for generating the trained practitioners and researchers it needs for furthering its importance and educate people why we need sustainability and where we come from and where we are going. So all those several global treaties in the past or even today are underdelivered. Sustainability has matured into a field built on measurable tool and almost a certain in local action that you can see in small towns in America to small towns in some Asian countries like Nepal or India and those kind of things. So this table condenses the chapter into two parallel stories. evolving ideas and evolving policies. We moved from Malthus 1798 limits to the 2019 Anthropocene vote. We discussed the intellectual understanding, such as ecology, ethics, and intrinsic value running alongside the political responses, such as legislation. I struck home to the SDGs, the gap between the two, or between what we know and what we agree to, and what we actually do is the central unresolved challenge of sustainability as a field. Thanks for watching.